Hey guys, today we're gonna tackle probably the most popular question on LeetCode, two-sum, and we're gonna use Rust to tackle the problem. Now let's read the question together, and then we can come up with a solution. So it says, given an array of integer nums and an integer target, return the indices of two numbers such that they add up to a target. Okay. So we're going to have a vector of nums and we're going to have a target. We need to return the two numbers inside of nums that add to the target. Okay, fair enough. And it says that you have exactly one solution. So that solves the issue of having a second solution. Every time we see a solution, we can just return that solution instead of continuing looping to find another solution. So that's good. And it says you cannot use the same element twice. So we need to make sure that we keep going forward and never backwards, or never on the same element. And then it also says you can return the answer in any order, which shouldn't be an issue either way, but that's neat. Anyways, so solution. The first brute force approach is, of course, just doing a nested for loop, right? So you're gonna compare the inner for loop with the outer for loop, and whenever inner for loop added by the outer for loop equals target, you return that tuple. Of course, there's a better way to do it. And what's a better way to do it? Well, what do we want? Well, we need to store, as we're looping through, we need to store the numbers in some kind of, we need to store those numbers. And when we want to access them, we want to do it in constant time and not O of n time. So how do we do that? So store something and fetch it in constant time. Well, that's HashMap, right? So we're gonna use HashMap in Rust to do that. So if you use HashMap, then what are we gonna do? Well, now simply we can just keep looping through. So we're gonna do for loop, or we can just say iterate over nums, right? And as we're iterating over nums, we're gonna find, hey, look, if the num, so this num can be anything, right? This num can be a complement, or it can just be the num that or like the target minus num. It doesn't really matter which one you store, just gotta be consistent. We can dive more into that when we're actually implementing it. Right now we're just going over like a really brief pseudo code, I guess. So yeah, if the num is in the hash map, that means we found a solution, so we just return. Else we add it to hash map and keep looping, right? Simple. So if it loops through the whole array and there's still no match, that means there was no match. However, it does say exactly one solution, so we never have to worry about that. However, we're still gonna go ahead and return nums 0 0. Oh, actually, you know what? You can just return. So we can just say wec, and it'll be 0 0. Okay. So a simple algorithm, and now let's go ahead and implement the algorithm. First thing we're going to define is the hash map. So we're just going to say let, and we're going to be changing this, so we need it to be mutable. So let mutable, and then we'll just say, what do you want to call it? Let's just call it, we'll just call it storage, and then we'll make that equal to, sorry, we need to define the type. So hash map, and what is the type of the hash map? Well, it's going to be I32. I32 is going to store the number we're looking for, and the next one is indices. Why are we storing the index in here? Well, here, if you look at it, it says to return, sorry, where does it say? Okay, it tells us to return the indices of the two numbers. So we cannot just return the two numbers that add up. We need to return the index, right? So that's what we need to store it. Then hash map that, and then we can go ahead and just do a hash map and then new. Okay, so that's done. Now let's iterate over nums. So how do you iterate over num in Rust? We can just do for. Oh, also do keep in mind that since we are storing the index, it's better to use enumerate and get the index as well. So actually, you know what, let's just do simple. So for first one, we're just gonna do the num, and then in nums dot iter, and then we also wanna get the index. We could just keep you know, like let mute and then idx, but we do have a built-in enumerate, so we can just use that. Rate, right? And then this is going to let's call it I index, and then okay, simple. Okay, and then Python came in. Okay, so now we're iterating through what do we need to do. So we need to first say if the num is in HashMap. So how do we check if the num is in HashMap? Well, we use get, and when we use get, if it has some, then we're gonna return, and if it doesn't, so if there's no match, then we're gonna add it, right? In Rust, we can use the match statement, which is really nice for get. It's more clean, I guess. So you can say match, and then we'll call it this is storage, and then we'll say match storage. Then we're gonna say get. Sorry, what do we want to get? Well, we want to get if the num is in. We also want to just do. So num is in that. We're gonna match it. What are we gonna get mad at? Either we're gonna get sum, and then in sum we're just gonna say, you know, n. We'll just n for now, and then. So that means it did find. In this case, we can go ahead and return. But let's just do that. And we want to dereference it, so we'll go ahead and do that, and we're gonna pass in the index. So simple, return rec, and so if it finds it, then getting will return this portion, which is the index, which is exactly what we want to return. So we're gonna say n, we're gonna return the n, and also the index, because that's the index the second index that I've found at. And then the other case is, well, what if it's no match? So in that case, you will get none. And for none, we can just go ahead and say, where's our hash map? So storage, and then insert. So now what do we want to insert? Well, what are we looking for? We're looking for get number. So if that number exists, so in that case, we need to store a complement. So to store, we're just gonna dereference again, and we're gonna say target subtracted by the num, right? So target subtracted by num. So if the target is 9, or sorry, if the target is 5, num is 3, then subtract them, you'll get 2, and then you will store 2. So next time when we have 2 in this, when we have 2 in the nums, it's gonna look if it has 2 in here. If it does have 2, that means we've got a match, and then it's gonna return. So that makes sense. And then we're also gonna store the index, right? Because the this n, that's what it's gonna fetch, the index. And yeah, that is it. So we're gonna match, and then lastly, we also need a return statement here. Like I said, we don't really care what we return, but we're just gonna go ahead and return a vec of, instead of 0, 0, let's just say -1, -1. Okay, so that should work. Now let's run it. It's probably never gonna work on the first try, but there you go. Okay, Okay, you know what? Let's just put this in curly bracket. Should have done that. Yeah, either just get rid of return. HashMap. Oh, did we forget to import HashMap? Yes, we did. Okay, we'll just do use std collections HashMap. Yeah, okay, I don't know how I missed this. It's whack. And that makes sense. That should work. What is the second error? Expect I32 found U size. Oh yeah, right. So enumerate is actually going to return U size. So we need to cast this as I32. Cast this as I32, and then run it now. Should be able to. Okay, well, let's get rid of that. Okay, sweet. So this worked. We're just gonna go ahead and submit it now. Boom. Okay, done. So yeah, this is the solution for Rust, solving a two-sum in Rust using HashMap. It's pretty simple. You initiate the HashMap. You loop over it. You need to keep track of the index, also the number that's here. Then you match it, see if that number exists. If it does, then you got your solution. Return it. If it doesn't, then go ahead and insert the target subtracted by num. Or if you would have just stored number here, that's fine too. But then here you would have to ensure that you subtract it by target. So whichever one works for you. But I did it here, so that's good. So target subtract, and then you also want to store IDX. Index is going to be U size, so you need to cast it to I32. That's perfect. Here it's never going to get here, but we still need to define return, so we're just going to go ahead and say vector -1 or 0 0. It doesn't matter. But yeah, that's the solution. I hope it was easy to follow along, and thank you for watching. Have a wonderful day.